Welcome to this video for MYP5 Unit 1, Lesson 1. It's going to be all about circles. So I've constructed a circle here with a compass. Hope you've got a compass. I've marked the center there, you can see it. Don't know why I've got my line tool on, but you can see the center at the circle, of the circle at the center of the circle. And what I'm going to do is just mark a couple of little random points on the circumference of the circle. Then I'm going to get my line drawing tool, and then from those 2 points I'm going to make a line up to a couple of lines meeting up at a third point on the circumference. So it could be up to there, or it could be up to there, or over there. Let's do one more. There, and then over to there. So all of those constructions involve a line from each of the 2 blue points there, and then they are meeting up at some third point on the circumference, and then at that third point they are forming an angle. So there's an angle in there, an angle in there, an angle in there, and angle in there, anywhere you want to put it. So what I'd like you to do is make that construction yourself on a rough piece of paper, and then make the 2 random points somewhere at the bottom there, and then join up to a third point from each of those 2 points at the bottom. And then I want you to measure the angles that you make. So that's the 4 blue ones I've got here, or you can do more than 4 if you like. And I want you to notice something about those 4 angles once you've measured them. Now, if you don't have an angle measurer, and you should have an angle measurer, you can still just get a kind of scrap of paper and fold it to the angle in one of those, and then notice something about the other angles as well. Okay, so try and do that, and I want you to pause the video while you do that, and then once you've finished it, you can unpause the video and see what you've discovered. Okay, so hopefully you've done that now, and you've unpaused the video, and you should have noticed something. So I'm just going to go to the top of this document here. So I'm just scrolling back a bit. This is my little exercise book that I've made, and it's going to have my notes. And my first note is, I've put a nice heading for the unit circle theorems, and the thing you should have noticed is that all of those angles are equal. So I've done an example here, and I've measured them all at 62 degrees. So wherever I put that angle from those 2 points, they are always the same angle. And that is called angles in the same segment. So in your notebooks now, please put the heading Circle Theorems, put a nice margin at the side of the page, make the book super neat, and draw the diagram super neatly with the key statement, angles in the same segment are equal. That's going to be our first circle theorem. So pause the video while you do that, please. And then we'll come back for the second one. Okay, we're going to have another construction now. So once again, I'm starting with a circle with the center clearly marked in the middle. There it is. And this time, our 2 points are going to be the 2 ends of a diameter of the circle. So there's the diameter of the circle just going through the center, and our 2 points are going to be at the ends of the diameter, and we are once again going to form from those 2 points a third angle up at the top. So one there, one there, one there, and so on. So from what we saw before, you should be expecting those angles all to be the same. But when it's the diameter of a circle, there is something very particular about that that you should notice. So once again, please pause the screen while you do that, and you can unpause it once you've figured out what's going on. Here's my notebook, and the thing that you should have noticed is that the angle in a semicircle is 90 degrees. So that angle that you got that was the same every time, in the particular case of being a diameter of a circle that the two ends are coming from, then you get 90 degrees every time. So once again, make that a neat note in your exercise book. The angle in a semicircle is 90 degrees. A neat note with the appropriate diagram in neat, please. Okay, here's our third construction that we're going to do. So this time we've got our circle, and we're going to put 4 random points on the edge of a circle. Now I'm trying to make it fairly sort of irregular as I can, so not necessarily a square or a rectangle, but kind of something a bit wonkier. So I'm going to join those 4 points up like that, like that, like that, and like that. So I've made a 4-sided shape, a quadrilateral, and because it's a quadrilateral where the 4 vertices, that's the corners, touch the circumference of a circle, that's called a cyclic quadrilateral. So it's a very particular example of a quadrilateral. And what I want you to do is measure the angles in that, but particularly think about opposite angles. So I'm marking those 2 opposite ones in blue, and then if I change to red for these 2 opposite ones, I want you to think about something with the red ones compared to the blue ones, and it involves adding things up, so bear that in mind when you're trying to do that. So construct one of these, construct a couple of these if you like, and see if you notice something about the red angles and the blue angles. Pause the screen while you do that, and then we'll come back to it. Okay, so here we are back at my neat notebook, and the thing that you should have noticed is that opposite angles in a cyclic quadrilateral add up to 180 degrees. So for example, in the one I've done here, the yellow ones are 78 plus 102, and that makes 180, and the pink ones are 114 plus 66, and that makes 180. So the observation to make about that one is that opposite angles in a cyclic quadrilateral add up to 180 degrees. So please have that neatly in your books to add to the notes with a nice neat diagram and everything looking splendid. Okay, for our next construction, I've got a blank circle again. I've got the center of the circle marked there. I'm going to have 2 points at the bottom, and they're going to make an angle at the center of the circle. So draw something to the center of the circle there, and you'll get an angle. It won't necessarily be the same angle every time. It depends where you put the 2 points, but that'll make an angle at the center. Then take the same 2 points, and we're going to make an angle at the circumference. That there, and that there, and then that's making an angle, let's change color, up at the circumference. So there is something to be noticed about the red and the blue angles compared to one another. So have a go at that, make the construction yourself, pause the screen, and once you think you've discovered something, then unpause the video and we will have a look at what you should have discovered. Okay, so here's my notebook again, and the thing that you should have discovered is that the angle at the center is twice the angle at the circumference. So for example, I got 84 at the center, 42 at the circumference. So whatever angles you had for that, the angle at the center should have been twice the angle at the circumference. Now that looks fairly straightforward in terms of the diagram. You get this kind of funny chevron shape, but that could take some different forms. So for example, you could get something that looked like that. So you've still got the 2 points there. From the 2 points, you're still making an angle at the center and an angle at the circumference, but it just happens that in this one they kind of line up down here, so you've got two things going on the same line, but the rule still works. So I'm still getting 84 and 42, the angle at the center being twice the angle at the circumference. Now it could look like this. So once again, I've got my two basic points. They're making an angle at the center, 84, and then from the same 2 points, an angle at the circumference, 42. So both from the same 2 points, but it's kind of confusing because they cross over. So it's not necessarily immediately recognizable as that particular theorem. And then again, you could get something like this, where the 2 points you start from are up the top. So the angle at the center that you get is a big reflex angle, in this case 148, and then the angle at the circumference is, in this case, 74. So it still works that the angle at the center is twice the angle at the circumference, but again, a little more difficult to recognize because you don't get this familiar chevron shape that you get in the original one. And because this kind of looks like a quadrilateral, then you might get confused with what we talked about before, which was cyclic quadrilaterals. So these cyclic quadrilaterals have got all four vertices on the edge of the circle, but this one here only has 3 vertices and then 1 vertex in the middle. So that's not a cyclic quadrilateral because not all of the vertices are on the edge of the circle, but it is the angle at the center is twice the angle at the circumference because you have the same 2 points making an angle at the center, 148, and an angle at the circumference, half of that, 74. So do pause the video and make sure you get that information neatly in your notebooks, please.